In this video, we'll discuss 5 basic things of a functions. Let's look at a simple functions f of x equals to x squared plus 1. This is a quadratic function, is also a member of polynomial functions of the second degree. The very first thing that we want to look at is the variables of a functions. In this case, the letter x represents for the independent variable of these functions, and f of x is a corresponding dependent variable of this function. And the next things that we want to discuss is how to graph a functions on an xy coordinate. As a reminder, x-axis represents for the value of independent variable, and the y-axis represents for the value of the dependent variable. And in this case, f of x and y are pretty much the same. They are represents for the same variable. Well, before we can graph a function, we always need to come up with a few points of the functions, and the easy way to do is to create a table of values. So there's 2 columns on this table. The first column, x, represent for the independent variables, and the second column is f of x. Let's pick the very simple, easy, convenient point when x equals to 0. So when x equals to 0, when you have a value for the independent variable, in order to find the value of the dependent variable f of x, you just need to plug the value of x into the description of these functions. So in this case, when x equals to 0, f of x will be equals to negative 0 squared plus 1, and the result is 1. So when f of 0, we know that f of 0 is 1. And then when we plot this point, the x value will be 0, and the y value will be 1. So in this case, this point is on the y-axis. All right, go to the next point, negative 1. And when x equals to negative 1, f of x will be equals to 0. F of negative 1 is 0. And we can plot this point when x equals to negative 1, y equals to 0. So the point is on the x-axis. And here's the coordinate of this point, negative 1, 0. Let's pick another point about when x equals to 1. When x equals to 1, plug it in the functions, you get 1 squared is 1, negative 1 plus 1 is 0. It's also 0, which means this point, when x equals to 1, y equals to 0, and again, this point is on the x-axis. As we already know about this quadratic functions, the graph of quadratic functions is a parabola. And in this case, connecting these 3 points, you can sketch a parabola, which is the graph of this function. It's a downward parabola because the coefficients of x squared is negative. Now, if we look at this point, the reason why I pick x equal to 0 first, because this is one of the special points. It is a y-intercept. So y-intercept is a point where the graph crosses the y-axis. It's a point where, the x value equal to 0, and whatever the point, the y value that you can find from the functions, it's going to give you the y-intercept. So in this case, the y-intercept of this function is 0, 1. And then these 2 points here are the 2 points on the x-axis, right? You see the graph crosses this point at this x-axis at this point, and then also crosses the x-axis at this point. So that means in these functions, you have 2 x-intercepts. And the question is, how can you find the x-intercept? So as you know that at these 2 points, the y value equal to 0, which means if you plug 0 into the y value, you will get an equation you keep the right side of the function the same, but the left side, the y value equal to 0, you're creating an equation. And if you solve this equation, you move 1 to the other side, or you move negative x squared to the other side, taking square root of both sides, you get two answers from these equations, positive 1 and negative 1. As a result, positive 1 and negative 1 are the two x-intercepts of this function. Well, the last thing that we want to discuss is about the domain and the range of the functions. So the domain of a function is a set of all the possible values for the independent variable. In a polynomial function, a value x or an independent variable, can be replaced by any numbers in the number lines from negative infinity to positive infinity. There's no restrictions for the value of x that would make the functions defined. That means the domain of these functions is from negative infinity to positive infinity as written in the interval notations, or you can use r as a notation for the interval. R means it includes all the real numbers. What about the range of the function? The range of the functions is a set of numbers that includes all the possible independent variables of these functions, right? So if you look at the graph, the highest point of the graph is at 1. The highest point of the y value of this graph is 1. If you look above 1, there's no other part of the function of this graph. But then if you look on the below 1, the graph can be extended down to negative infinity. The y value of this graph can be extended down to negative infinity. That means the dependent variable, the values for the dependent variable can go up to 1. But it can extend it down to negative infinity and go up to 1. So that means the range of these functions will be from negative infinity up to 1, including 1. Because when x equals to 0, then y equals to 1. So that means you're going to have a bracket on the right of 1. So if you're using the interval notations to represent the range of these functions, so this should be a good representation for the range. Or you can use another notations using f of x or the y. You can say that y is less than or equals to 1 to be the range of the function. All right. So again, this video shows you 5 basic things about functions. First, the variables of the function. Second, how to create table values of the functions, or how to come up with the function values for any given value of x. And then we talk about how to graph a functions using table of values. And then we talk about y-intercepts and x-intercepts of the function. And the last thing is about the domain and the range of the function.